Welcome to the Forces and Friction Notes. Let's learn about forces and friction. The first thing we need to know about forces is that a force is a push or a pull. Anytime you push or you pull on something, you're exerting a force. Two forces that we'll look at in detail later are magnetism and gravity. Magnets, as you know, can push or pull other magnets and metals, whereas gravity is an attractive force, it pulls. When we measure forces, we measure in a unit called newtons, named after the scientist Sir Isaac Newton, and it's abbreviated N. We measure in lab newtons using a spring scale, and you can see a picture of a spring scale in your notes. On that, usually we'll have 1 unit on one side and then newtons on the other side to measure the force. Forces, like velocity, have a direction, and they also have that force magnitude, which is measured in newtons. And we show that direction with an arrow. So if we put a force onto this block, we would have an arrow showing the direction we're pushing it, as well as a magnitude in newtons. Now, forces can either be balanced or they can be unbalanced. And an unbalanced force will cause an object to change its motion. It can set it in motion, it can slow it down, it can change its direction, and that is an unbalanced force. Let's take a look. So if I want to get this ball rolling, I have to apply a force to it. Bam! And it'll go in the direction that I push it. So that was an unbalanced force. Now, to get that ball moving, we had to apply a force, and this is our model of that. We have an arrow and we have a magnitude. So it doesn't matter what the magnitude is really, but let's have this ball moved by 5 newtons of force to the right. Try that in your notes now. So what would it actually look like if you drew this? You would have 5 newtons and you'd have an arrow. Now, how about if we were going to the left? Draw another circle, another ball with an arrow, and now 5 newtons to the left. This seems rather simplistic. However, getting the basics and knowing what they mean really helps us later to understand more complex models. If something's balanced, it means we have the same amount of force pushing in opposite directions. So there's no change in motion. There are still forces present, but there's no change in the motion. So let's take a look. So I'm pushing on the shopping cart, and the forces are balanced. It's not moving, even though I'm applying some force to it. The brick wall, of course, is applying a force in the opposite direction. So there's no change in its motion. A classic example of balanced forces is book on a table. Gravity is a force pulling the book down, but there's what's called the normal force pushing that book back up. The book is not changing its motion, so the forces are considered balanced. Now, if we have all these forces acting on an object, right, we can look at what's called the net force. Overall, what might that force be? More often than not, there are a lot of different forces acting on objects that we have to consider when looking how it might change its motion so we can predict what will happen. So let's look at an example with a whole bunch of forces on one block and determine the net force. So in this case, we will have 5 newtons to the right and 2 newtons to the right, but we'll have 3 newtons to the left. What is that final force going to be? So friction is a special kind of force that we always have to consider because it's always going to be slowing things down, because friction opposes motion and it goes in the opposite direction of motion, and that's what slows things down. So we have 2 surfaces rubbing together, we get friction. and that friction will produce heat. And we also know that that friction, because it's going in the opposite direction, is going to slow things down because it's operating as an unbalanced force. Friction can be a balanced force if an object is having a force on it where the velocity doesn't change. But in most cases that we look at, we're going to look at how friction slows things down, so it's an unbalanced force. 4 types of friction. The first type of friction is static friction. You got to get things going, and that initial static friction, what's trying to keep it there in place, has to be overcome first. The next kind of friction is sliding friction, and this is when you try to push something across a surface and it's just going against you trying to push it. So if you've ever tried to push furniture or something else across a floor, it can be quite difficult. If you need to reduce sliding friction, use ice. We can reduce that sliding friction by giving it wheels, giving it rollers, because rolling friction is less than the sliding friction. So anytime we see wheels, we can think about rolling friction. Rolling friction is less than sliding friction and involves wheels or rollers. Finally, we have to consider fluid friction. Air and water can produce friction. Think about airplanes and ships, rockets, anything going through a fluid has that rubbing of the air, that fluid or water on it, and that is considered a fluid friction. It's what aerodynamics is all about, reducing that amount of friction. We can reduce our rate of fall by using fluid friction, like using a glider